For a lot of people, artificial intelligence is a very, very hot topic. It's one that you see a lot of times dominate the trades and the press, not just in utilities, but across the board. There's good reason for that. But like with any very, very hot topic, it's difficult to separate the fact from what's actually being spewed out. And so if we can have an opportunity to go and have a good discussion about that today, would love to do that. Any questions you guys have, I'll be at the booth later. If you feel like there's a conversation you want to go and continue with. Let's. All right. So I think the question everyone wants to ask is, what is AI, and what does it mean to us? Why do we need it? And from a utility perspective, there's a lot of opportunity here, but as I had mentioned, it's very difficult to separate what is real from what everyone is saying. AI, at its most basic form, is a series of systems that act intelligently. And you can think about it from a siloed system where there are very autonomous decisions that are made in one particular silo, or you can think of it as a network of intelligent decisions that are made across the board. Now, siloed decision making is great, and that's actually a lot easier to go and do than this whole mesh of decisions that can be made, including a number of different data sets and data sources. So for instance, SCADA, advanced metering infrastructure, third-party data like weather or like seismic data, vegetation management. We have a very nice demo over there if you guys want to go and take a look at these things. That is cool, and again, each one of those, if we can go and show that, is great, but the key is to get it and bring it all together. So I think the point that I want to impress upon everyone is that actually achieving true AI is a journey. It is not something that you can flip on the switch tomorrow and say, hey, I've achieved artificial intelligence. We're not hitting the singularity tomorrow in any of these industries, and even the ones that are particularly advanced, we realize that there's a long way to go. Buzzwords like machine learning and data science are tools by which we can go and achieve this, but it's not something that we can go and feel really good about and feel like we've done our job in 2018. Now, that doesn't mean that you can't achieve value before achieving true AI. And I think that the key in a lot of the conversations I've been having with our customers is that there is value along the way, and we'll outline what that journey is actually going to go and look like. It's something that makes us feel a little bit better about the investments that we're making in it, and then the notion that this can actually, every step in the process can be additive in a way that we can actually get to a spot where we feel really good at the end of this picture. The other thing that I'd like to say is that it's never going to be done. There's going to be new and more impressive things that we can go and do once we get to the end step of what we consider AI today. But there is good opportunity, as I had mentioned, on the path. And additionally, good news, a lot of this is actually, the hard work is actually already done. So if you think about the data that's being collected today, if you think about the control room that's being run operationally, that is truly the hard part. The lights are staying on. We have a network that we feel pretty good about, so how do we go and harness that data now? And that's the question that we need to ask ourselves. As we go and think about how we move forward, now we start to incorporate the power of the cloud and our ability to go and hyperscale out any series of data that we've gone and collected, use data science algorithms, build data science algorithms to be able to go and drive that stored data that we have in a way that can be truly agile, and then at the same time drive insights to things in the control room, other places you want to go and answer. So let's talk a little bit about what that journey looks like, and I promise you, this is the only wordy slide that we have on here, and I'll take you guys through a step-by-step process here. As I had mentioned, a lot of the hard part's already done. Ingestion, you guys already have data in these silos today. You're looking at the data. Sometimes you're making decisions based on the data. Other times it's just going and kind of after a month or two, we don't think about it anymore. That's fine. That's a great step to go and take, and again, it's additive towards what the end state is going to be. Stage 2, operationalization, so making decisions based on that data. What would you do differently if you had that data in a way that you can go and make decisions upon it? And if you can go and do that, again, in a more siloed perspective, that's a good thing. That will help continue to keep the lights on, the grid running. Now, It is not the end state by any means, but we should all feel really good about that, and we should continue to go down this path. Now, stage 3 is interesting, and it's actually based on the conversations I've been having with a lot of customers, the hard part. So when we talk about convergence, how do we make sure that the data sets that we're collecting in all these different silos can actually go and talk to each other? How do I know if I pull on a string over here, something is going to go and happen over here? And how do I know if that relationship is causal instead of correlative? That is a lot of effort that requires expertise within the domain. It requires a lot of expertise within data engineering. We haven't quite gotten to data science or machine learning yet, but it also requires a lot of cultural embracing of making sure that the data is all in one place. Now, when we talk about one single window pane, what that means when we refer to it is being able to see everything on one screen. Now over here, if you've seen the network digital twin, that's actually a really cool way to go and visualize it from a geospatial perspective. That is a lot of value that you can go and unlock, because then you can make decisions across the board to see what that true impact is, and then you have the historical view of a lot of what's going on as well. Stage 4, and actually I will caveat stage 4 and stage 3, sometimes we see an inversion of optimization and convergence. Some people go straight from operationalization to optimization, and that's again the siloed strategy where you want to go and build a data science model, you want to go and use machine learning on one specific siloed entity. We here at GE, I think part of our product strategy is to make sure everything gets converged first, so that you guys feel very, very, very nice about the entire suite of activities that you have to go and do. Let's talk about optimization a little bit. And I think when we hear intelligence, when we hear artificial intelligence, we think, all right, let's throw a machine learning model at it, and then we're done after that. And that's not the case. If anyone has dabbled into machine learning or data science, a lot of what happens is what we call garbage in, garbage out. And if you don't have the data engineered in the right way, the data is not clean, if it's not structured, or you don't have a good understanding of what the data is, then the output and the outcomes are not going to be as valuable as what they could be if you were to do all of that work beforehand. I'll leave you with a quote at the very end to talk about that. The other thing is, if you don't have very described outcomes, if you don't really know what you want to find out at the end, going and just running a bunch of algorithms to see what's cool is not going to be the best use of your time. So how do we get around that? One of the ways we had talked about was having a very, very disciplined set of data engineering, ingestion processes to go and make sure that everything is modeled in the right way. The next is domain expertise. And knowing, all right, with these outcomes, what are the decisions that I truly want to make, and what are the levers that I can actually pull to be able to make those decisions? Domain knowledge is I can't tell you how important in being able to understand that. And we think here at GE, this is one of the strong suits that we have. There are a number of other people that would be able to go and say that, but the convergence of both of those together is an interesting opportunity for us to help a lot of you. The third piece, and this actually will kind of blend from optimization into self-learning. The third piece is what we like to call business rules. So what does it cost if you were to make a decision and the decision turned out to be wrong? What would the cost be if you didn't act and something bad happened? Infusing those actually allows you to go and optimize your decisions so that your systems engineer can come down on Tuesday, sit down with his or her cup of coffee and say, all right, well, what do I need to do today? What's the stack ranking of decisions that I need to make? If you have a proliferation of data and you have a proliferation of output on your data science models, sometimes that can be really hard to pull apart. So when we talk about, it's called overage and underage cost, or in a lot of other ways, false positives, false negatives, and true positives. If you can plug all three of those into the data science model, you can actually go and optimize output based on how you feel on any given day, and the cost of making a decision or not making a decision based on that model. Stage 5, again, this is the end state, but as I had mentioned, it's a bit of a moving target. The moment that we get over here and 2019 or 2020, there's going to be new methods, new ways of collecting data. The business model may have changed, so it'll be a continual process. It'll keep us all employed for a long time because it's really difficult to just go and do. When we say self-learning here, the outcomes driving the algorithms. We'll go back to the true positives and the false positives and the false negatives. If you're able to go and ingest the outcomes of the decisions that you go and make and plug it back into the model, then the model knows what variables are driving what's real and what variables are driving the things that it thought was real and ended up being false. So if you go and plug that back in, the model will continue to retrain itself in a way that's very meaningful. It's again a moving target and one that we're going to try and attack, but it is a ways out for a lot of the people that we've gone and talked to. So that's about it for my little talk here today. I think the question is, what now? I think one of the first things that we should all look at is where we are in our state of this journey. And some customers and some it doesn't have to be in utilities. Everyone has a place where they should be. Take a hard look at where you are. Have a discussion. I'm happy to go and help audit that. If there's anything that I can reinforce, again, the end state is very, very great, but make sure that we're going and capturing value along the way so that it's not this big, huge capital investment that you're not going to see any value from until the end of the project 2, 3, 4 years from now. The quote I wanted to leave you with was one by Abraham Lincoln. He said, if you give me 6 hours to chop down a cherry tree, he's going to spend the first 4 hours sharpening the axe. And I think there's a lot of value in thinking about going and doing that. So spend your time sharpening your axe. Try and separate the fluff from what's real, and figure out how you can achieve value right away as opposed to 2, 3, 4 years from now, because that's going to be way too late. Thank you, guys.